G'day Year 7 mathematicians, and welcome to week 2 of the final term of your Year 7 maths curriculum. So this week we're going to be looking at recognising quadrilaterals first before moving on to doing some work with some pie charts. So can you draw a line under last time's work please? And the title is Recognising Quadrilaterals. Make sure you spell that correctly, it's the top there, and today's date please for me. So first up, your do now task is you're going to have this table drawn out into your book for me please, and you're going to draw a triangle into each of these spaces to make the two terms accurate. And are there any that could in fact not be filled in? Okay, so those that feel confident, pause the video there, see if you can fill in as many of those as possible. If you're not too sure, if you let the video roll on, I'll shut some answers, and hopefully that first line will give you a little bit more of a clue and a bit of a help and guidance there. Okay, so there's a small clue. So remember, scaling, no sides are the same. Isosceles has at least two sides the same. Equilateral, all three sides are the same. Okay, and if we were to fill in this first one, acute angle, that is one that is less than 90 degrees. So three acute angles there, A, B and C, all three are less than 90 and all three have got different side lengths. Isosceles, so we've got the two angles along the base there. We've given the letter A, two of those are the same, and then B would be the remaining one. And then equilateral, obviously all three angles must be 60 degrees. Okay, so that's a little bit of help there. See if you can fill in the other 9. Just be aware that maybe not all of them could be filled in. Okay, so well done to how to go at those. These would be the answers here. You cannot get a right-angled equilateral, because again, equilateral, all three angles must be the same. Right angle means 90. We can't have three 90-degree angles. It must add up to be 180 total for a triangle. Likewise, we cannot get an obtuse equilateral. Equiangular. Awkward word to say. That just means, again, equiangular. Equi meaning equal. Like, remember we had equidistant. Everything was an equal distance apart for those parallel lines. And those would be the angles on that. And those last ones, they say 60 degrees there. So well done if you filled in some of those. If you didn't, just jot those correct answers down for me now, please. So today we're going to be able to recognise parallel and perpendicular lines. We've had a look at those definitions from last week. We'll be able to recognise types of quadrilaterals and then be able to recognise and use those properties of quadrilaterals. So first up, I'd like you to sort the shapes into two groups, those that are rectangles and those that are not. So pause the video and have a go at some of those and think, can you have a definition for what a rectangle is? I'll put up a definition shortly and then you maybe want to change around with some of your answers. Okay, so in terms of definition, what we're going to go for as a definition of a rectangle is a four-sided flat shape where every angle is a right angle. So I'd like you to copy this down exactly and with the diagram, because it's very important notation there, to show the equal sides we do with those lines. And as there are two pairs, we've given one of the pairs one line, the other pair of equal sides we've given the double line, to show that they're not all the same, but there are two pairs of equal sides. Each internal angle must be a right angle, and the opposite sides are parallel and of equal length. Okay, remember parallel, those are two lines that are equidistant, they're always the same distance apart, and they will never meet. So, can you decide what the properties of the quadrilaterals are? So, another time to draw out a table exactly as it appears there, and we're going to fill in all of the gaps here. Okay, so pause the video, make sure you get pencil and a ruler to draw the table exactly as it appears there. And I'll take you through the first one on a square, then I'd like you to have a go. I'll see all the answers will be up, so if you're struggling, you can play the video forward a little bit just to pick up a few more hints, but see if you can fill in as much as possible on your own. So a square. Angle properties, all four are 90 degrees. What do we know about the side lengths? All the sides are the same length on the square. Parallel sides, opposite sides are parallel, so you've got two pairs of parallel sides. And the diagonals, they bisect at 90 degrees. Okay, we'll have a little bit more of a look at that in greater detail at a later date. But if you were to draw the two diagonals, they would meet at 90 degrees. Okay. So see if you can have a go using that information you filled in the top one for square to have a go at as many of the rest as possible. If you get stuck on one, jump onto the next shape there for me. Okay, the remaining answers are coming up for you now, so if you can just correct what you've done and fill in anything additional. Okay, it's very important that you fill in this table fully for me, please. I see everyone in their book with this table drawn out correctly. Okay, next up, and using some of the information we've just put there to help us, you're going to draw those 8 shapes, and again, exactly as they appear with those lines. So remember when we've got our lines to show that they are parallel, and to show that they are of equal length. The angles wise, we've covered them in. So on the third shape on the top row, we've got 2 pairs of equal angles. Obviously the ones that aren't shaded in are equal, and the 2 that are shaded in are equal. Okay, and then you're going to draw them. Make sure there's enough room under each shape. So you're going to name what each shape is, which I'd recommend you do in pencil in case you make a mistake. And then on the next slide, there are 8 properties. Obviously it says cut them out, but we're not going to be printing and sticking this all in. You can just write these next to it. And again, use a pencil to see, and you're going to match up those 8 shapes with the name of a shape, and then each of them will have one of these properties underneath. Now this is a bit of a lengthier task, so I think you're going to probably need to give yourself a good 10 minutes and jump between those slides so you know which parts you're going to do. And then in a moment, I'll take you through the answers for that. Okay, well done for having a go on some of those. Hopefully you've not cheated and jumped ahead. And we can see some fantastic, neat work into your books there. And those would be the answers that we were looking for. The names of the shapes above them, then the shape drawn, and then we've got the properties for each of the shapes. And again, just make sure you've got that written accurately into your book, please. Next up, we're going to skip that bit because that would be something we'd need to do more in class, and we don't have a Geo board. It's essentially a board with pins in so you can put some elastic bands on to make shapes. So unfortunately we don't have that, but hopefully at some point we may have a chance to revisit that. So, bit of a true or false time now. There are, what have we got? 6 questions on there. Okay, and I'd like you to have a go at true or false for all of them there for me, please. Pause the video, decide on 6, then I'll take you through and you can give yourself a score out of 6. Okay, obviously you can have a little think back to what we've already covered for the lesson. Okay, so all quadrilaterals have at least one line of symmetry. Okay, that is false. All quadrilaterals have at least one pair of matching angles. Also false. You might think of some shapes that definitely have at least one line of symmetry with the quadrilaterals, likewise one pair of matching angles, but you've got to just think of one shape to prove it wrong. There might be 1,000 shapes that prove it right, you've only got to prove, say, one that proves it wrong to be false, because it says all of them. Trapeziums have only one pair of parallel sides. That is true. Okay. A square could also be classified as a rectangle. Is entirely true. If you think back to the definition of a rectangle, okay, we've got 2 pairs of our equal length sides, and all of the internal angles must be 90 degrees. Okay, that's exactly true of a square. All shapes with 4 right angles have 2 lines of symmetry. Okay, that would be false. And the diagonals of a rectangle are always the same length. That would be true. Okay, next up we've got a little bit of a bonus on top of this true or false, and this comes directly from the Riddler himself. I'm going to put up a statement, and I want you to suggest a shape that makes that true. Okay, so they're going to appear one at a time, and I just want you to think of when I say quad, we're just being a little bit lazy there, and we're not going with the word quadrilateral. I'm a quadrilateral, all my sides are equal, but all my angles aren't. So I'd like you to give me a suggestion for what quadrilateral that could be. So in that case, I was looking for a rhombus. Next one. I'm a quadrilateral and I have no parallel sides. What could that be? There I'm looking for an arrowhead or a kite. Okay, again, think back to the 8 shapes that we drew earlier and attached the names to. I'm a quadrilateral and my diagonals bisect each other at right angles. There we're looking for a square or a rhombus. Next up, I'm a quadrilateral. My diagonals are not equal, but they cross each other at right angles. That again would be a kite or an arrowhead. I'm a quadrilateral and I have only one line of symmetry. This now is quite a few different answers. We have a kite, arrowhead, or an isosceles trapezium. I'm a quadrilateral and some refer to me as a regular quadrilateral. Regular quadrilateral. That there is a square. That's a square. And I'm a quadrilateral with no lines of symmetry. So what of those shapes that we've seen has no lines of symmetry? That is our parallelogram. Okay. And I'm the only quadrilateral with 4 lines of symmetry. Is a square. Okay, and then last but not least, a little bit of bonus work for some of you. Here is, can you create a flow diagram that includes all the different types of quadrilaterals? So this is my example I've started with. Does your quadrilateral have 4 equal sides? If you say yes, you go to the right hand side, what shapes that can be? If you say no, what's the next question that you could try and split that up to be? Okay, you don't have to start with that question. You could start with another one, perhaps. Does your quadrilateral have 4 equal angles? Have a yes and a no side, and where would that take you to? Let's just see if someone can come out with a nice, interesting flow diagram for those. Okay, and Jack has done a plan of a building, and he said that the building is in the shape of a rectangle because the opposite sides are equal in length, which he's drawn on clearly, the lengths there. What else would he need to show to check that he is correct? What else do we tend to put on a rectangle that identifies it clearly as that shape? Okay, so I want you to just have a think there. What else could be added to make it even clearer? So I think on this case, we could easily add the symbol for the right angles in each of the corner to show that all the internal angles of this rectangle are 90 degrees to prove that even more. Okay, and last but not least, there is a little bit of an exit ticket for those that wish to do that. You can draw a favourite quadrilateral, name it, write all the properties you can remember, and identify any angles and parallel lines on there with the correct notation from earlier. Okay, and that would be the end of this first lesson. And I say, so next time we're going to have a look at the pie charts. So in the meantime, I will double check on your Hegarty clips that you need to cover for the week. And I'll in fact do the quadrilateral one straight away, so that's fresh in your mind now, and then come back and we have 2 more lessons to cover for the rest of the week. So look forward to speaking to you again soon then, and in the meantime, look after yourselves, Year 7.